Here begins our lesson on practice test B on chapter 4, looking at the second half, the quantitative section of the aqueous solutions. Our first objective, concentrations of solutions. This objective is going to really focus on two formulas: the definition of molarity in terms of moles per liter and dilution problems, where MV equal MV. And I'll model some of these examples and ask you to follow along, checking your work as we go. Calculate the molarity, the solution volume, or the number of moles or grams of any solute given the following quantities. Include the units in our problem and in the answer. Number 1 reads, what's the molarity of an ethanol solution containing 50 grams of water with a total volume of 250 mils? 50 grams of ethanol is our solute. 50 grams of C2H5OH. We're going to use a mole map conversion to convert our grams of the solute into moles. And add with me. 12 times 2 on the carbon, plus a total of 6 H's, plus an oxygen at 16, gives you a molar mass of 46 grams. Grams divided by molar mass turns us to a mole. I set that under a liter unit to turn it into the volume to find our molarity. Grams, 50, divided by our molar mass of 46, divided by 0.25 liters, and the molar concentration, 4.35 molar units. Number, label, unit in my answer. How many grams of chloric acid are contained in 750 mils of the 0.1 molar solution? My given quantity, 0.1 mole of chloric, it comes from 8, and the acid rules, chlorate, ClO3 minus 1, so my acid formula, HClO3. 0.1 moles for every liter of solution, the very definition of molarity. We'll multiply that by the volume in a liter unit, so the liter cancels. I'll just set that over a 1. Liters are gone and we're at moles. Using the molar mass of HClO3 set over a 1 converts the molarity unit times 0.1 molarity unit times the 0.75 liters. Oh, I didn't do the molar mass. I'm sorry. Back the bus up. 1 plus 35.5 plus 16 times 3. I missed doing that. My molar mass is 84.5 grams. Now I'm ready to do 0.1 mole times 0.75 liters times 84.5, the molar mass of our acid, and 6.34 grams of HClO3. What is the molarity of sodium ions in a 0.75 molar solution of sodium sulfate? Sodium sulfate is a salt that has Na2SO4 as its formula. When this strong electrolyte dissociates, 2 sodiums and a sulfate polyatomic ion are released. We're being told that we have a 0.75 molar solution of sodium sulfate. We're being asked to calculate that concentration of the sodium ions that's released. 0.75 times 2 would show us a 1.5 molar concentration of sodium, twice the number. 1.5 molar concentration of Na+1. Number 4. What is the molarity of magnesium sulfate dihydrate solution that contains 7.25 grams of the solid salt in enough water to make 750 mLs? Magnesium sulfate dihydrate. This is reminding us that hydrated crystals have water as part of their structure. That will play a role when we look for the molar mass of our solute magnesium sulfate dihydrate. We've weighed out 7.25 grams of MgSO4 dihydrate, 2 waters. I want to convert that into a mole unit, so I'll need a molar mass. When I find the molar mass, an Mg plus an S and 4 O's and the weight of both waters is necessary. Mg, 24.3, plus 32 for the sulfur, plus 16 times 4. MgSO4 is 120.3. And in addition to that, we have 2 water molecules, each weighing 18. When I add on the weight of 2 water molecules, the whole compound is 156.3 grams for our molar mass. MgSO4 plus the weight of 2 waters is 156.3. I'll set that in a conversion now using the volume to get to a liter. Moles per liter is the molarity of our solution. So just taking a look at 7.25, the mass of our solute, divided by the molar mass, 156.3, divided by 0.75, and we get an answer of 0.062 molar units. MgSO4.2 waters. Number 5. How many grams of aluminum chloride are contained in 500 mils of a 0.25 molar aqueous solution? Our given said that there's 0.25 moles per liter of the solute aluminum chloride. When I multiply that by the volume in a liter, the liter unit cancels and we're at moles. Moles times molar mass converts me out to a gram. Aluminum has a molar mass of 27. Chlorine with 35.5, but there's 3 of them. So the entire molar mass of 133.5 grams of AlCl3. Moles times volume times molar mass. .25 times 0.5 times 133.5. And it looks like 16.69 grams of AlCl3. Our last one in this section. Tell me the molarity of barium ions in a 10 molar barium phosphate solution, a dissociation equation. Barium phosphate is a salt, Ba3PO4 taken twice. When it dissociates or lets go of its ions, there we go. There are 3 barium ions at a +2 charge and 2 aqueous ions of phosphate at a -3 charge. If the salt concentration was 10 molar, and we'd like to know the barium ions, it'd be 3 times the value, a 30 molar solution of barium. First section was all about the molarity in the Part A. Let's talk about dilutions in Part B. To calculate the volume of a more concentrated solution, that must be diluted to obtain a quantity of a more dilute solution. The molarity and volume of the first solution is equal to the molarity and volume of our second solution. What is the molarity of a solution that is formed by diluting 500 mils of a 5 molar solution to a total volume of 1 liter? What I notice is that on one side I have a liter unit and on the other side I have a milliliter unit. All that matters is that they're the same. So since I've written out 500 mLs on the right and 1 liter on the left, I have to adjust one into the other. 1 liter is the same as saying 1,000 mLs. Now I have like units and I'm able to solve for my molarity of my base, sodium hydroxide. 500 mLs times 5 molar divided by 1,000 in the first molarity is 2.5 molar NaOH. MV equal MV. 500 times 5 divided by 1,000. How many milliliters of 12 molar sulfuric acid are necessary to prepare 500 mils of a 0.01 molar solution? Solving for V1. Since I placed a milliliter into my equation, a milliliter will be the unit that comes out. 0.01 times 500 divided by 12, and I found 0.4, well, my calculator says 0.416, but I'll just do 2 decimals, 0.42 milliliters of sulfuric acid. Let's keep going. Tell me the molarity of a solution that's formed by diluting, so we want M1. We're diluting 300 mils of a 0.25 molar solution. Notice 300 mils of 0.25, those go together. We're pouring in enough water to dilute it up to the 1800 mil mark. What's the resulting concentration? 300 times 0.25 divided by 1800. And M1 is 0.042 molar units of NaOH. How many milliliters of 5 molar sulfuric acid are needed to prepare 50 mils of a 0.15 molar solution? 0.15 molar times 50 mils divided by 5. I would need 1.5 milliliters of my sulfuric acid. The major skills of Objective 4, solving molarity problems and dilution problems.